Hello guys, so today I'm going to show you what zeroing actually is. Uh, s- I want to tell you that I'm not a shooter. I haven't even touched a dart in my life, and I just play a lot of games, and that's what made me curious. And so I took saw a lot of videos, and couple of them were pretty helpful, and so I will give the links of those videos in my description box. You can see them. So you might ask that what's the point of watching these videos when I myself learned from those videos. But the fact is that I think they missed a very critical point that's important to those to people like me who don't even understand what they are trying to finally convey at the end means. I think that critical point I will bring today. I'm not sure that if I am 100% right, because I don't know even the S of shooting, but what I felt and what I saw is what I'm going to bring out. And the fact that if you have any problem, if you are a shooter, or you're a professional kind of weapon expert or anything, please do comment that where I am wrong. It will obviously be helpful. And if you think that my video misguides you, please do dislike. Yeah, please do dislike. Okay, so let me show you what does actually mean. So let me keep my let me raise my phone up. So the first question is that why do we zero? Okay, so do we zero every time? No, we don't. There's a thing. Say, so first, let me tell you why do we even means our scope and barrel position. Because first, it's an important thing. Okay, it's just a little thing. Say this is our gun. It's a linear thing. Okay, it's not like it's kind of dented. It's just let's consider this as a straight linear surface. So just a gun kept straight, and this my scope just kept 90 degree here. Just kept above the gun in the scope. Initially, every person will think that the scope and the gun is parallel, means the scope is just kept aligned with the gun. But actually, this is not the case, and the reason is very simple. Say there's a person, and you are actually sniping him. You are aiming him. You are obviously aiming him in his head, so the aim line goes straight. There's no deviation. But when you shoot, assuming that there is no wind, the bullet does not go right or left, the bullet does not go over the person's head or touches the ground in front of his feet. You shoot, it goes straight. It will hit him somewhere in his chest, or if it if my image is strong, it will go straight and it will hit him in his abdomen. So the solution is that the scope is not actually kept like this. Wait, just a minute. Just a minute. Sorry for that interruption. So the scope and the scope's thing and the gun, they're not actually, the scope is not actually aligned. So how they do it? You'd see from what I got that the gun is like this actually, not completely like this, and the scope is like this. So the gun is not straight with the scope. You see, earlier the gun was straight with the scope, so it's a 90-degree thing. But this time, the gun is pointed. Here I have pointed it pretty much. You have It's pointed upwards, but actually, there might into this gun due to a lot of accuracy. Wait, just a minute for that interruption. So as I'm saying that the in real life the gun is point tilted a little upwards with the scope. So, and why does it help? So here's the thing. Say the person is like same and you were shooting him, is you were aiming him at his head. The bullet, assuming that moves in a straight path, will after a certain distance fall. Okay, it isn't that it will go on traveling. So I think you have that sense. So it will travel a certain distance and it will fall. Consider you were kicking a football, you just kicked it, and then the football won't just go straight, it will follow a parabolic path, will follow an inverted U-shaped path, and eventually will happen that this line of aim and this line of that bullet, they intersect, and that's the head, and here we have a shot. So this was important, a little knowledge was important. That's how actually the scope and the rifles are aligned, are fixed. You may not, it might not be visible that this difference too much, but into this gun especially, but that's how it's kept. It's not completely straight, not completely parallel, there's is some difference between them. Anyway, so what happens, why do we zero? Say when we aim, say, let me think that uh, this this is my, just, okay, okay, sorry for that. Say this is my barrel and this is my scope. Okay, okay, and here's my person, I'm aiming him. What happens is that there's a wind that blows from right to left. For example, uh, if I shoot him, if I say, imagine that you are aiming him, the bullet won't travel his path directly. Okay, the bullet will shift to the right, or say the wind is blowing from right to left, the bullet will shift to the left, but keeping this same. For example, this is the person and he's standing on a straight way, and the bullet will either, say I am aiming him, the bullet will not directly go to his head, it will either go on the right side or it will go on the left side, but not to his head, because a common thing, a common sense, wind is actually blowing, and when an object is being pressurized by wind or under the influence of wind, it will obviously follow the direction of the wind. So especially light objects like bullets, where uh, and obviously I think the bullet won't go straight, you can guess it, the bullet will either go right or go left. So what to do, how, so my question is, what to do and how to actually shoot him in that circumstances, in that situation. So that's a very common point, that you will say, okay, then let me shift my gun to the left if my wind is blowing from right to left, then if I shoot here, then I I will shoot him, then my bullet would automatically go to the left and reach to his head. Or let me give my gun to the right of his head, so if the wind is blowing right to left, if I shoot him, it will automatically go there. So you are changing your gun, okay, you are changing your gun and then you are experimenting, but uh, there are there's a way to actually determine the point. For example, in this case, you never knew that if you aim here, the bullet will fall here. It all came from the wind thing. Okay, assuming you know the bullet will fall here. Normal circumstances, you know. What you what you don't actually knew was that that the bullet will fall here. You know that the wind was blowing right to left, but you never knew that the bullet was flying here. So obviously, if you now kind of change this gun to, say, the bullet changed by 2 meters, okay, deflected. In real life, the situations are more complex. There's a lot of physics, a lot of maths, but it's just I'm telling you. The bullet deflected by 2 meters from, say it's 0 and it's 2 meters, so I'm going to shoot from 2 meters left, so my bullet deflects by 2 meters and it's it hits right. Okay, sorry for the wait. So uh, I think I made that point that why do we actually kind of adjust before shooting, before we adjust our right and left points. That's means we actually adjust our gun, our shooting, our gun's position as per the wind's position, as per the wind's movement, right or left. But how to detect this point, that where my bullet actually hits, that if it's my push. I'm using another video slang which I'm going to list, but I find it so suitable that if this is my point of hit, this is my point of aim, this is my point of impact, how do we actually get it? That detection of point is known can be done through zeroing. There actually isn't just wind blowing right or left. A bullet can fall up or down. So what I'm trying to say is that, say you are here and the guns, say my gun is a standard position from here. Okay, you are my there's a range of my gun, the maximum distance that my bullet can travel. That's, say, after zooming everything and after aiming him directly at his head, is not within my range. My bullet travels, say, a particular distance and falls in front of his feet, or say he's very close to me and I am aiming his head, but owing to my gun placement the bullet falls over his head. Might happen, not completely unnatural. I'm kind of, my gun isn't, or this thing is a little, what I'm trying to say, I think you got this point, that if you are here and if you are too far from my gun's range, is my scope, if you are too far from my gun's range, my bullet falls here, so obviously I will raise my gun so my bullet travels a greater distance. If you are still not in my range, I will raise my gun further so my bullet travels a distance. It won't go on forever. For example, if I means keep my gun perpendicular upwards, it will fall like this, or I don't know how it will fall, but it won't go this distance. So it will obviously have a limit. So it will go unless it finally hits. So here is the thing. If I aim here, let me draw a clear image. If I aim him, say he's a big head, him here, and it happens that the bullet falls in front of in front of his feet. Okay, that the bullet doesn't even go there. I have to then raise my gun up, cause my bullet missed him by few feet, sorry, by few units, by few any distance unit. If I raise my gun up, then I might hit him here somewhere in the bad position. If I raise my gun up also, if everything is right, I may still give him in his neck or in his head. So how much should I rise up my gun? Here's the difference. Earlier, when the wind was blowing right to left, how much should I shift my, say this is my gun, wait, say this is my gun, sorry for my, I bite my, how much should I right or left? But here is the thing, that how much should I lift my gun up or down? That's the here. When the wind, when the target's not in range, how much should I blow my sorry sorry, how much should I keep my gun up, place my gun up, or how much should I say this is a hill and this is a person you have to shoot. You cannot just, if a standard gun is placed like that, you cannot just shoot him. Obviously the bullet, or the bullet won't just, it won't, bullet has a far reaching kind of distance, fine, the bullet will hit here. So how much you, in this case you have to lower your gun so that you can get him aim and further take the shot. So how much should I kind of say steer my gun up? It won't be, steer won't be a good language. How much can I tilt or sometimes move my gun up, or how much should I move my gun down is also, or what is the point at which, after which, say, you know here that after I hit him in this point, I'll hit him and it will fall at this point. So there is a difference, say there is a few meter difference. So say, so if you raise your gun by that meters, for example, then if you shoot, now your gun, actually things are more complex, but I'm just telling you in the simplest way possible. Say your gun hits, when you hit him in his head, the bullet falls down by 4 meters. So actually if you raise your gun by 4 meter, your gun obviously by 4 meter, and you then, so you may get a hit. And here's the same thing for a particular meter down. So calibrating, adjusting, a more non-technical language, adjusting your gun as per wind, range, and all of, and there are a lot of conditions, you know, but these are the main: wind, range, etc. You zero to find that point, a point of impact, point of actual impact. See carefully, my point of hit, my point of hit, my point of hit, if I was shooting, if my point of hit isn't my point of actual impact, it fell down, okay, so my point of actual impact is this one. So finding my point of actual impact, that's why we zero. Okay, now I think that was a little clear I've been made. So then you think, then another point, a coordinate system, a little and a very super simple mathematics out here. Coordinate system. Okay, now what is a coordinate system? You have often known numbers, you count 1 2 3 4 0. Those who have further attended mathematics, they go negative, -1, -2, -3. So actually whatever numbers you count, they actually all fall on a number line. Very cool. This is a 0, this is the origin, and this 1 2 3 4, this all goes up to infinity. Here is 1.5, 1.2, so there are infinite numbers between 0 and 1, the decimal, but here we don't consider it for simplicity. Then -1, -2, -3. So say I told you that how much was your marking when you attempted the wrong question, and you say, I don't say you got a negative mark on right there, so you say I got -2. So that's a number line, And a coordinate system is actually a two-dimensional thing. What does this mean? Say a rectangle. It has a length, it has a breadth. So there's no height. So there are only two dimensions, a length and a breadth. So coordinate systems actually, and the most simplest sense, the intersection of these two number lines in this way, that this is the origin 0, 0, this is the, and this is the number line that we just saw in our figure. This is 1, this is -1, this is -2, this, and this is the number line. You just think about rotating this number line clockwise. Just means what I'm just telling, that this is 1, this is 2, this is 3, this is 4, this is 5, and this goes on all up to infinity. And then this is -1, this is -2, this is -3, this, they're all minus. Okay, so this is positive x positive, and this is known as the y-axis, is known as the x-axis. So this positive x, positive y, this positive y, negative x, this is negative x, negative y, and this is negative y, positive x. This four combinations are known as quadrants. So this first quadrant, this second quadrant, this third quadrant, and this fourth quadrant. And any point, get mark my words, any two-dimensional point I can create out of this. So here's how. Sorry for the wait, they're extremely sorry, there are a lot of interruptions in the video, but sorry, extremely slow. So how to make a point? Say I tell you make a point 1, 3, you will go 1 unit up. Okay, so 1 unit, so you first, the ever since it's a two-dimension is formed, so you go 1 units up here, and you then move 3 units up this line, this y-axis. Okay, and this point is, sorry for the wrong sorry for the bad drawing, but this point is 1, 3. Let me show you again. Say I told you to make the point 5, -2. So you go 5 units right here, and since I told you that this is negative y, you go 2 units down here, and then this point that is formed, this is actually 5, -2. Say I tell you to make a point 4, 4, so you go 4 units, say 4, 4 is my option, is my choice. So actually you go 4 units up, you can think it's in this way, 4 units up, you draw a line up a straight, a perpendicular straight 90-degree line. I hope you know 90 degrees, it's just a straight line, there's no bend, is 90 degrees as it is. It's how you define, just symmetric 90 degree. You draw a line from y-axis 4 units, 90 degree, and then where they meet, this is 4, 4. The same for all. Say I tell you to plot this point -2, 3, you will just go -2 units. You will start from 0, you will go -2 units to the left. See here, one thing, when I tell you minus and then a number, then minus means the first thing you have to pay attention is when I tell you to point A and B, since every point is from a combination of x and y, you will get only these two numbers only. So these two numbers only, there are only two x's, so only the two axis unique combinations make different numbers. So only two so if I tell you that there's a point called A, B, C, D, E, this actually isn't possible, because from A axis you will make one, you will get the point with this intersection with B axis, and then you don't have any C, D, E axis anything. So that's when you have fifth dimension, that's from every axis you will getting one point, and when they meet together. Anyway, that's a long thing. A and B. Say when I tell you A, if A is positive, say A is 7, A is say 3, so you go 3 units right first. Okay, get it right. And if A is negative, say negative 3, you go 3 units left. That is, you actually find that -3 point on the left of this quadrant. And then there comes second, the y-axis thing, the B. So when I tell B is 5, so say 3 comma 5, you go 5 units up, and then you have a point finally, 3 comma 5. You don't draw these lines, and it's just for telling how these points are formed. Actually, you only mark these dots. So this is 3 comma 5. If I tell you 3 comma minus 5, you go 3, you are 3 units, you go 3 units right, and then go, since this is y, negative part, you go 5 units below, and you seek for that -5, join it, and this is 3 comma minus 1. Perhaps applicable with anything. I tell you -1 comma say -2, so since it's -1, you go 1 units on the left of the x-axis, the first part -1. You either go, and I say -1 comma -4, you either go 4 units down from -4, or for your simplicity you go 4 units down from the origin only, meet where this draw two perpendicular lines, and where they meet this -1 comma -4. So I think I made how a coordinate system, how thing say positive A comma positive B is actually A units up here. This is A comma 0, and then in its B units up here. That is when you have, so this point is 0 comma B. Carefully note, 0 A comma 0 means no y axis thing. You just move A units to the right, since A is positive, A units to the right, and you move 0 units up. That is, you stay there. Here's the same thing, you don't move any units right or left, you move 0 units right or left, and you move B units, and where this point is formed, comma P. So this can be formed through combination of anything, A minus B, or C D, or this is minus, so C minus D, and since this is positive, this is negative, this negative, minus C minus D, you can form with the negative thing positive, and then that is minus C comma B. So anything, so it's very pretty much powerful. That's the beauty of mathematics. So why was it important? Why did I tell you this coordinate thing before 0? So here's why it is important. Pages, let me turn my page. Sorry for that. Say, now pay attention. There is a target, and this is my crosshair. Almost every person, when they look through the scope, they aim through the scope. Those who have played games, those who have, I assume that who are seeing these videos, they have seen some movie games or tested at the fire range. So this scope, it's a perfect circle. Okay, it's just a diagram. My diagram is not perfect. Anyway, say you aim for his head. You are aiming him at his head. I'm telling you that the bullet is going. So the first thing is think that this is but a coordinate axis. This is but a 2D plane. This whole thing, and I think you can get it. Every scope has its then 2D plane, and this thing where these two things mean, this is 0 comma 0, this is the origin, not this thing, this is a person's head, so don't confuse, this is the origin. And when I'm aiming to the origin through some physics and mathematics, some beautiful physics mathematics out there, I'm telling you, calculation of say I'm telling you the wind's blowing 2 meters right. So how this 2 meters was determined, how this say wind was blowing 3 meters right, so how many meters wind is blowing, that is not this video's purpose, that's mathematics, physics, and that's a different this calculation out there. So that's a mechanical and a pretty much imaginable thing, that's a pretty kind of scientific part out there, but I'm telling you the location, how to make that point. So somehow you have got the information that the wind is blowing 2 kilometers say per hour left to right. For simplicity, I'm just telling you that the wind is blowing left to right, and the bullet is deflected by 2 kilometers. Just get it right. I cannot explain more simply. From where you shoot, the bullet is getting deviated by 2 kilometers. So it's the first thing of you. So you will think that if I shoot at 0 comma 0, if I aim at the origin, then my bullet is landing 2 meters right. Assume that you are in the target's range, there's no bullet falling, there's no bullet falling in front of his feet, there's no bullet just crossing over his head and then falling beyond him, there's just wind is moving right, bullets falling right or left. So as I told you, there is no up or down, that is just no y-axis movement, so there's only a positive 2 comma 0. It's going just 2 comma 0. This is my point. This is a number line, and say this is 2, so this is 2. So this is my point. Almost. Now if I say my bullet is moving 3 kilometers right, this was right. So if I say my bullet was moving 5 kilometers left, so if I shoot him here, it's gonna move 5 kilometers left, it won't hit him. If I shoot aim it at the origin, it will move 5 kilometers. So the point of impact is, as I told you, since we move left, we are in the negative number line, it's minus 5 comma 0. So this is your zeroing point. Why is this thing a zeroing point? Here's why. So I think you got it. So if I tell you this moving x kilometers, positive 3 kilometers, you can mark positive 3. Negative 2 kilometers, you can mark negative 2. You can mark 2 kilometers left here. So say this is my origin 0 comma 0, and I am aiming that person at, say this is my person's head, I'm aiming that person at minus 5 comma 0. Obviously this means I have shifted my gun a little left by say for simplicity 5 kilometers only. Then and my barrel is here. Be careful, I have shifted my gun, but since my barrel and my gun are at the same thing, I mean like this, they're all on a miss. It's not that my barrel is here and my gun is here. My barrel and my gun is always on the same line. So I have changed my scope, my whole gun to the left, and now I am actually aiming him on here in this point. So when I shoot, my bullet will initially go straight, and it will deviate and hit him 5 kilometers here. Another example, say I tell you the wind's blowing 9 kilometers. It's pretty fast. So since this is 0 and my you have to carefully I think you can make this out and I can aim 9 kilometers. I can mark 9 kilometers on my zero on my scope. Okay, that's gonna help me. I can mark 9 kilometers. So if my scope doesn't have a opportunity for 9 kilometers, my scope is very false, it's 3 kilometers. Obviously for bullets that are going 9 kilometers right, I cannot even zero it. So forget shooting, you have to be a very good professional shooter then. Anyway, so if I am aiming this person at the origin is 9 kilometers, so when my point of zero is 9 comma 0, so when I aim him, I've shifted my gun. Okay, I'm now aiming him at this point. I'm keeping my gun straight. Okay, I'm keeping my gun straight. I'm just, so think like this: you were actually aiming and then you moved your scope just right. You were not moving up or down, you just move right along the same line, and happened that target was up. So when I shoot my gun, my barrel, scope all at the same place, my bullet goes right. So you get that coordinate and this wind connection, right? I'm telling you again, real life situations are more complex, more difficult, but that's just like a basic bony frame cage, the rib cage of it. But it's not even a rib cage, like it's like a little image of how it actually happens. Now is another great thing: the up and down. Say that my target is here. The up and down is a little hard, but you can guess it. And I'm aiming him at the origin, and happens is that, say my target is here. Okay, I'm aiming him at the origin, and happens that my bullet initially goes and then falls here. Obviously this means my target is at a few distance from my range, because under normal conditions, if I aim him, if any person was here, say my bullet can go, say, obviously the distance traveled is more complex calculation, but for you seem to say 3 kilometers. So if a person is greater than 3 kilometers, my bullet won't go by 2 kilometers. Calculations are more complex in real life. It's just for your simplicity. So if I raise my gun, it will travel this 3 kilometers, it will cover additional kilometers, and it will hit him finally at one point of my own. So how much should I raise my gun? Back in the question. So I say the target is too far. I say my point of impact, my point of aim is every time 0, 0 initially. My point of impact is 0, -7. That is, when I hit him here, it is coming here. That is, it's 7 units down since it's negative. So that means if I hit him at his head, it's hitting at the ground or something like that. Obviously this means that the target is far away. So or if I tell you, okay, let me for simplicity tell you the down case first. Or if I say you the target is the bullet is hitting 0, -6, obviously this means the target is if I hit here, the bullet is falling, so the target is far away, so I have to raise my gun up. That's what I thought. Obviously if this, and if something starts from this kind of if my gun was like this, and and when I rise up, my gun is falling like it will cover that distance, this distance, and then will fall an additional distance. So if I aimed him at this thing, it would have touched the feet, but if I aim my gun, it could touch the head. So if I raise my gun up, so what I do, I just raise my gun up, no down, no left. The wind is as the bullet is traveling straight. Listen, the bullet is traveling straight, it's not deflecting. So keeping the scope, I just raise my gun up, aiming him on his head, and by 7 units, and da-da, here is he now in my aim. I've just raised my scope, so my aiming point is now 0, -7, that I tell you, or 0, whatever it might be. So when I shoot my bullet, everything in place, everything in line, my bullet goes up and finally hits him at the head. My gun is actually placed up. I hope you get this. This was very important. Say my target was 2 meters above. Say my target was 0 point -2. So if I aim him at hit, now I'm moving my scope all up by 2 units, and I'm now aiming him at 0, 2, and then 0, -2, extremely sorry, and then since 0, so no right, no left, the wind straight, my bullet's traveling steady, the bullet went up and then fell on his head. The downscale is not very different. The downscale, sometimes it's very rare. It's not that it's you are hitting him, and sometimes it's very rare that it's mainly in those downhill, not downhill cases, when you actually have to lower your gun, because why will you keep him? Like, it's very rare that the bullet is crossing his head. It's too close. So let us assume that the target is very close, but your gun's placed as it is, so it's crossing his head. So the same case now is going to be positive, so you have to obviously you have to lower your gun so that it touches him. Or what I mean to say is that, say I'm aiming him at 0, 0, and my bullet falls now here, which means obviously my bullet falls beyond his head, somewhere here. So obviously I have to lower my gun so that I can shoot him. So I tell him my shot is 0, 3, which means that I am now, everything is constant, lowering down my scope, and now I'm aiming him at 0, 3 units up. Okay, see, now my bat position or my abdomen is at 0, 0, which means I've lowered my gun. Earlier my head was, now my abdomen is. So whenever I shoot the kind of bullet, it's just, I mean, it's not too much hard to explain, but it's, say, it will just go down. It will just like this, it will hit him down. It means my bullet is like this. Okay, so when I hit him, it will just fall down by 3 units. Means what I'm saying is that, say I hit him by this, my gun is now lowered, so it will fall down by 3 units and it will hit him. Means, let me explain it to you properly. Okay, this was my target, and earlier my gun was placed, so I lowered my aim was him, but when my gun was placed, so I lowered my gun a little bit, and now it's hitting him, right. So earlier when my target was here, when I hit him, when I gave him a shot, it hit him 0,3 units. Now when I'm shooting him, I'm lowering my gun. So when I'm lowering my gun, the target is not upward, my gun is lowered. Okay, that is when I'm lowering my gun by, that is, here it is. My bullet falls on his head. My bullet does not go cross that. My bullet, since the bullet falls kind of 3 units up, since I'm falling 0,0, my bullet is crossing that unit and is falling, and is actually falling 3 units down. Is when I shoot him, that is what I mean, that if it's 0,0, and I'm aiming him at, okay, say this is 3,0, sorry, 0,3. So when I'm aiming him here, actually when I'm aiming him here, my bullet kind of falls here. Sorry, extremely sorry. I'm kind of reading, being a little bad explainer out here. For sorry for the inconvenience, but the down thing is a little hard to explain. Say this is when I shoot, but this is 0,0, but this is 0,3. This is where the bullet actually lands. And so when I lower my gun down by when I shoot him, when I aim him at 0,3, that is when I'm lowering my gun down by 3 units. That what I said, I'm lowering my gun down by 3 units. I'm not uppering him, I'm lowering my gun down by 3 units. That is, now he has become in front of my gun and his abdomen. I'm aiming him at 0,0, my origin, my crosshair, and my gun hits as 0,3. So means, what I'm trying to say is that so my person is right here, and this is 0,0, and when I hit him, it's moving, it's crossing, let's say 3 units distances. It's 0,3. So when I lower down my gun by that unit, and when I say hit him, I have to lower down my gun. Obviously earlier my gun was this. Say I lower down my gun, then it hits this. My gun was initially there. When I lower down my gun, then it hits this unit. Okay, I know how I was a very bad explainer out here, but the lowering case is a little difficult to, but you can imagine it, right? It's just the opposite of uppercase. So I'll make one video up for that lowering case, for the downhill case, but that's, you can think that as it like that, or like this, that say I'm aiming him at, say this is my 0,0, say I'm aiming him at, my gun is placed like this, 0,0, and say he's my, what to say he's my person I want to shoot. Okay, and this my gun's normal placement. So if I'm somehow aiming, this downhill case is very absurd as well. Yeah, it's means you just, anyway, you just lower your gun. I'm telling him that this is not the point, my point of hit is a little up than it. That's if it's, I'm aiming him at here, if my aim is, my point of hit is 3 units up, say. So I should aim him 3 units down. That is, my point of aim should be 0, 0 should be 3 units down, and he should be aimed like 0, 3. So it goes down 3 units down like this. So that's like a case. So I think you kind of got that, but even if you don't, I think most of you haven't, so please do comment. I'm going to work harder. So what happens is that many happens the combination of it, that is 2, 3, the real life situations when wind is blowing. Say this is my 0, 0, and this is my scope, this is my target, and I'm telling him to move at it's to shoot say 2, 3 units. So the wind is blowing right by 2 units, and then I have to lower down my gun by 3 units. So this is my zeroing point. That is or for my convenience I say 2, -3, a realistic situation when the target is also far and the wind is blowing say right. So I have to, so if this is my target, this 0, 0, I'm aiming him, the wind is blowing 2 units right, and the bullet is touching 3 units below his feet. So this is 2, -3, 3 units below negative and 2 units right. So it's touching 2 units, so I have to raise my gun. So this is my zeroing point. Okay, 2, -3. So I have to raise my gun all over here, all over from here. So if this is my point of aim and this is my point of intact, I have to raise my gun. You can do it in a lot of ways. You can first go 2 units, change your scope 2 units right, keeping the y-axis fixed, and then you move like kind of 3 units, -3 units, kind of. You just go, what I mean to say is that you just go 2 units right, means since you have to aim him using this point, so you just, so the bullet is actually going 2 units right and then -3 units. You can think it like that. So you can raise your gun by 3 units, and then you can shift your gun by 2 units. That is if this is 0, 0, you are now aiming him at this point. This is the target's head, that is 2, -3. So you got it. Earlier your scope was this, now your scope is almost over his head and by some distance. So when you are going to shoot him, the wind's gonna, the bullet's gonna go 2 units up, this is gonna go right and then down and then hit him. And a lot of combinations, say 5, 6. The downhill thing I'm weak at, but I'm still trying. That if it's 5, the wind's blowing 5 units left and the 6 units. So this is 5, this is 0, 5, 0, and this is 0, 6. So this is your zeroing point, and this is your target you are aiming. So what happens is that you actually, so the wind's blowing 5 units and then it is crossing, then it's moving 6 meters above his head. So actually bring him, aim him at this point, that you are actually aim him at this 5, 6 points. So you get it, you lowered your scope. All your point was there, now your point is here, your head is here, and you then shoot. So there's a bingo when you hit. So the bullet goes left unit, kind of, and then it moves. You have lowered your scope, so it moves, it touches his heads down. His bullet isn't going below, above him. You have, since you have lowered, touches it. Here means head. This is just for illustrative purposes. It's touching it as feet, but it's touching it as head. for your that's how everything is done. That's if your scope and real life situations are more complex. There's a wind effect. There's actually, this might not be true, the wind's effect get multiplied as it goes, but there's is a zeroing point that is found by this method. That when I tell you that this is my zeroing a system of coordinates, it's actually an imagination. Real life things may be more tough, but there's one point, one unique point always there as per the situations that is determined by using mathematics, physics. So for your first enjoyment, I'm going to give you a gameplay video on actually how it is done. So I think you will enjoy it. So hello, so as I said that I will be showing you a game. Actually there are a lot of games in Android, but this one is the closest to realistic sniper shooting and activities, so I chose this one. In computer there are many games, and if you want this if you like this game, the lone wolf that I have in my phone, in computer you can go for Arma, Sniper, Ghost Warrior, or any game that comes, or there are a lot of games. Wait, sorry for that okay, sorry for that ad. Turn my internet off. Okay, let me show you first from range. There are my gun's range is actually 100 meters. So to show that effect of zeroing, let me take the largest distance. You will get to know why. See, this blue dot right here, this thing exactly is my 0, my origin. You can see this as if a coordinate system, as I showed you. This 0, this blue dot right here. Wait, let me take this thing a little up. Okay, so this blue dot right here is my origin, and this thing is my x-axis. So my wind is blowing from left to right. That's why it is in the right, it's in the positive x-axis, because then when I shoot, my bullet will go left to right. And see the main thing, the y-axis here. This is the this is the y-axis. This is a negative y-axis. As I told you, if my pointer is in the negative y-axis, which means that the bullet's gonna fall down. So you're gonna see that the bullet's gonna fall down, so we have to raise our gun by that unit, so that the bullet after being raised falls down by that unit only. So if I hit in 0, 0, it will hit this point. It's too clumsy. Okay, so what I'm saying, that if I hit 0, 0, the bullet will hit the ground. Means if I aim at somewhere, the bullet will fall by these units. Actually it's more complicated by it, but this is the basic thing. And if you forget this thing, if you think that my guns is in range, my bullet will go right by right, will deflect right by this meter. So you can see this is a coordinate system. So let me show you. If this is the graph, this 0, 0, this this where these crosshairs are meeting, if this thing is 0, 0, this crosshairs meeting point, then actually my pointers, my zeroing, so how you zero, so my pointers is actually x coordinate here, the wind coordinate, and the y coordinate here. So when I meet those 2 points, as I showed you, you get your zeroing point. Say it's like 2, 5 or anything, you get this zeroing point. That's a unit right, b unit down, and this a comma b. Had this green pointer been here, it will be have been minus a, because I told you is the negative x-axis, and had this it's a comma minus b. Okay, because the bullets, because it's in the negative y-axis. So had the pointer been here and here, I would have said you it's minus a comma positive b. So let me show you what. So our zeroing point is actually this and this, or better, yes, this point. So actually this point is our zeroing. So let me show you. So when I hit, say, to him, you will see a beautiful thing happening. The winds blowing from left to right. See, it's moving in an anti-clockwise direction. So you saw that when I shoot at this car, or for clarity, when I shoot at this buildings, this bomb, it hits that unit. You see, it first goes by right unit, it first deflects to the right, and it falls down by the distance from this origin to this green point. So my zeroing point, as I said, will be this comma this. So imagine, right, that this and this has been already fixed as my somehow zeroing point, and keeping this in place, I move my gun upwards. That is here, kind of thing. That is, see, now I'm aiming using my zeroing point. So if I hit now, let me take you to a target, or okay, this point is okay. So if I hit now, my bullet will first go right and then it will fall down. Actually it will go like this, but technically it's like going right and then falling down, or falling down and then going right. So actually it will from the gun, it will go right like this, fall down. So let me take you. So wait. Okay, I just moved a little far. So as you see, I'm now aiming using this my zeroing point, and so let me shoot. I think I'll hit it. Okay, so that's how it works. And see, my zeroing point has now been fixed every time. So I'm not so wherever I'm my zeroing, wait, I'm not, sorry, my zeroing point is fixed like this. So whenever, so my zeroing point is sometime always here. So this point, the point that is imaginary form. Actually things are more complex, but that's how you look at a zeroing point. So whenever I hit, I don't hit, sorry, whenever I hit, I don't hit, I always hit like this. You see that imaginary point is also moving as I change the coordinate, that corner thing also. So when I don't hit, I hit him using my imaginary point. That is first, or you can, here is the intuitive way. You know that the bullet will fall down, so you raise your fall down by say 5 units. So you raise your gun by 5 units. You know your bullet will go right by 10 units or some 2 units. So you move your bullet by left by 2 units, so that even when it goes right by 2 units, you will hit him. It will hit it, and even if it falls down by 5 units, it will, after it will get a ascending height of +5, and it will then fall down by -5. Thus this is my zeroing point. So this one's it, you see. So that's how you zero. Let me show you a game, a mission that's I have taken. See, wait. So this game is actually fantastic. So you see My target is 290 meters, and perhaps this is the most fascinating way. uh, so if I hit him here, wait, so what I'm trying to say, if I hit him here, the bullet will, it will hit him in his head. No, it won't hit him in his head, it will hit him at this point, because the bullet falls down. So by that point, so it will hit him in his neck, and then it will hit him a little right on his kind of left shoulder. So the bullet will hit him here, so in the coordinate system here, comma here, so this point the bullet. So that's why I am not using this origin. So let me show you. If I had I aimed, you see it kind of, it somehow does the headshot, but actually it goes for the right. To make you believe, let me show you one. See, this is not the head. Okay, so if I aim for the head, it won't actually go for the head. See, sorry, but it won't exactly fall into the head. And here's why. If I aim him here, it won't exactly fall into the head. You saw that thing? I'm aiming him into the head only, but, or very close to the head, but actually isn't falling to the head. It's touching the neck, as I showed you. So this units, they felt they actually they touched the head because it was a little up, so it was like this thing. So if I actually aim him here, it's still the head. It's not, it won't fall. See, it is touching the neck, that is falling down by that unit. So as I told you, my zeroing thing will be like this. For your reference, for your proper view, this and this. So whenever I join these points, this positive x and negative y, this point will be zeroing this point. So whenever I will take my gun down, I won't aim here, but I will aim him here. I will aim him using my zeroing point. So this is my zeroing point. So you see how difficult it is for snipers, actually real life snipers. So this is my zeroing point. So carefully see, I am aiming him in his head only, using my zeroed point and not the origin. So let me show you that this thing's real. So that's the thing. So it's failed because in the story you have to play in a different way, but that's so. I think if you don't understand, sorry for my callous way of guiding you, but that's the closest I can get you. Thanks to mathematics and physics for so many kind of zeroing things. But if you have any problem, please do comment.